thermodynamics, and maybe we shall discuss one problem like this. Okay. Now, we talked about thermodynamic principle, and we loosely talked about entropy as an entity. Entropy is almost like if we in mechanical engineering terms, if we talk it, entropy is del Q by T. Now then, what is del Q, what is T, all these things will come into picture. But let us go back to our the basics of first law and second law of thermodynamics. Mass and energy, actually whatever happens, why we are talking about the mass and energy transfer? If you think about, let's say there are four basic devices of a thermal power plant. Now, boiler, turbine, condenser, and pump. These are the four basic devices. The boiler is a separate entity. You can, if you are a boiler designer, boiler, turbine. Oh God, my hands are frozen. My handwriting is not that bad, but it's boiler, turbine, condenser, and pump. These are the four basic devices. So in the boiler, you just put in the coal. There is the pulverized coal there. Then the high pressure, high temperature steam goes into the turbine. The turbine, you just direct the high pressure jet steam onto the blade of the turbine. Turbine rotates. And you know from the electromagnetic radiation that in a permanent magnetic field, if you rotate a conductor, IMF is generated. And that is the reason why we are trying to extract mechanical power out of the thermal power plant. So boiler, turbine, condenser, and pump. Now, the thing is that you can concentrate only on boiler. You can concentrate only on turbine. If you are a turbine designer, you can, if you are looking after the condenser, you can look after this condenser and this pump, all these things. Okay. Now, these are all, that means you will have a system. These are all, we call these, in thermodynamic parlance, we call it control volume. Control volume. Now, in some cases, control mass and energy is transferred across the boundary. Mass and energy transferred across the boundary, sometimes it is not. Sometimes it is not transferred across the boundary. For example, let us talk of a thermoflask. In the thermoflask, you want to keep your hot coffee or hot tea hot. In this freezing atmosphere, you want to keep it hot. That means you want that mass and energy, that whatever the energy containment in that flask would not cross the boundary. That is a closed system. That means that is a closed system. Closed system is what? Mass and energy do not cross boundary. What is that boundary? Boundary is that the thermoflask is the boundary. The rest will call it as the universe. Why I am talking of all these things is that slowly, because we are talking of the environmental engineering, now first and foremost thing is that the local entities, all the smaller entities like the turbine, like the boiler, like your vehicles, these are all small entities and it is interacting with the environment. That means uh, it is the contributor to the world pollution. So when we talk about the environmental engineering, ultimately we are talking about a system called the earth or the world, right? So now the world we will talk is the as the ultimate in environmental engineering, our focus will be the earth and the world. So therefore, we have to build our concepts from these systems, from the control. These are the technical terms. Control volume. Control volume is whatever the. So, for example, the boiler, whatever the contents of the boiler at one side in the boiler, it is receiving the cold liquid, not really cold, warm liquid from the boiler feed water pump, and the other side, it is releasing the high pressure, high temperature steam onto the next location, which is turbine. Now, so therefore, these are the technical thermodynamic terms we have to come to terms with. That means control volume, closed system, open system. That means when you have a closed system, you also have open system also. That means in open system, both mass and energy cross the boundary. I'm sorry, I will not be able to send this one. This must be fair. People are waiting outside. I would be glad to let them in. Let me see. Yeah, there are. 40 seconds. Take the link. Admit. Yeah. Okay. In the open system, both the mass and energy cross the boundary. In most of the cases, we have the open system. For example, boiler is an open system in which it is receiving pressurized water from the pump and it is releasing high pressure, high temperature steam onto the turbine. Turbine is receiving high pressure, high temperature steam as an input and it is releasing low pressure, low temperature steam, and the byproduct is the is your mechanical power in the form of mechanical work, turbine blade rotating. In the condenser once again it is receiving the low pressure, low temperature steam from the turbine, which we call it exhaust steam from the turbine. And this exhaust steam is needed to be cooled and finally passed on to the boiler. So, finally passed on to the boiler feed water pump. Now, so the condenser, once again, it needs a cooling agent. So, in every phase, you will see that there is a transfer of energy and there is a transfer of energy and mass for the open system is taking place in order for our objectives to be fulfilled. In this case, power plant, our objective is to produce power. Therefore, our we will deal with these kinds of open systems. Now, thermodynamics, open system, and first law of thermodynamics. See, there is a term called thermodynamic cycle and thermodynamic process. Thermodynamic cycle and thermodynamic process. What is process and what is cycle? Thermodynamic cycle is basically you execute a path, you go to Godiahat, you come back home, you are executing a cycle. If you don't find Godiahat is a beautiful place, you can go to some other place also. You can come back, but your first starting point and the end point should be the same. There is this thermodynamic cycle. That means the thermodynamic properties of our entry point, or rather, the starting point and the end point, thermodynamic properties remains the same. If you come back to this place, once again you get to have a feeling of same temperature, pressure, and things like that. So that is thermodynamic cycle. Process is that you go to one place to another, and you can go by different paths also, thermodynamic paths, right? So the process is that the end points are different, therefore thermodynamic coordinates are different, therefore the law will be different. Basically, the first law of thermodynamics is basically first law of thermodynamics for a cycle. First law of thermodynamics. I'm extremely sorry, my handwriting is really pathetic today, not because my limbs have gone numb. First law of thermodynamics for a cycle. Mathematically speaking, cyclic integral of del Q is equal to cyclic integral of del W. In other words, cyclic integral of del Q is equal to cyclic integral of del W. Why this is why it is not dq? This del Q and del W are inexact differential. What do you mean by inexact differential? It depends on path followed. Exact differential does not care for the path. Whatever path you take, that is called exact differential. Whereas del Q and del W, they are the inexact differential because it depends on the path which is followed. Del Q is the heat interaction, and del W is the work interaction. Del Q is the heat interaction, and thermodynamics is basically, it is a, and thermodynamics is basically, thermodynamics is basically subject which deals with interaction of heat and work. Heat and work. Why heat and work? Why so partisan attitude? Because heat is the source of all our heat is the source of all the there is yeah, Rupak Parui. Okay. Yes. Why we talk about heat and heat? Heat is the source of all the energy. Sun is the source of all the energy, and then if we go further, that the coal, which is basically the metamorphed plants, which had been buried for millions of years, the fossil fuel, everything. Now that we know that they contain energy, and we have developed technology how to harness that energy. So therefore, the how to harness the energy from the fossil fuel is taught in thermodynamics, because that is the basis of civilization actually. If you see it, the electricity has basically the civilization has gone leaps and bounds forward due to the invention of electricity, and the thermodynamics actually deals with the interaction of this heat and work. Now, so del Q is an inexact differential that we have talked of. What it says, that thermodynamics for a cycle says that cyclic integral of del Q is equal to cyclic integral of del W. Let us say we have a process. Uh, Let us say we have temperature entropy diagram we have got, and there is one process goes like this, it process goes, then it comes, then this is the process. Let us say this is 1, this is 2, this is 3, and this is 4. So let us say the process starts from, this is a temperature entropy diagram. S is the temperature entropy diagram. Now the process starts from here, it goes, this is the compression process, then the heat addition process, then the expansion process, and then the heat rejection process. These are the 4 processes, let us say. Now this is a cycle, 1, 2, 3, 4. This is a typical thermodynamic cycle wherein the process starts, for example, in IC engine, internal combustion engine, what happens is that you take in the air inside the cylinder, top dead center to bottom dead center, some amount of air is sucked in, and then you compress it from 1 to 2. So the volume reduces from 1 to 2, and at that point of time, you just inject the fuel in case of diesel engine, or you spark the initiation of the firing, you start. So 2 to 3 is the heat going inside this cycle, and this is the compression work. That means out from the outside, if you have to compress something, From the outside, you have to do the work. Let us say WC is the compression work. Now, after this heat addition is there into the system, this explodes. Explosion, when the explosion happens, 3 to 4 is basically it is giving you the work output. W E, work output. ये वर्क आउटपुट के लिए हम इंतजार कर रहे हैं. Actually, this is the work output that we are looking for in all the IC engines, basically bus, truck, vehicle, whatever, whichever it employs the IC engine principle. There, the expansion, the WE is the thing that we are looking for. And finally, there has to be some amount of heat rejection, which is Q2, let us say. Now this executes a cycle. Now it says the first law of thermodynamics says del Q is equal to del W. Del Q is equal to del W. There are two heat interactions. There are two heat interactions. That is Q1, which is in, and Q2, which is out from the cycle, and two work interactions, which is WC, which is into the cycle, and WE, out from the cycle. Yes, the other two. So it says that cyclic integral of del Q, is equal to cyclic integral of del W. That means del Q, cyclic integral मतलब इतने साइकिल में कितने हीट इंटरेक्शंस हुए हैं. Now the convention we use is convention, because why we have to use certain conventions? There are people waiting outside. Ankita Verma, please come in. Okay. Convention is that heat in is taken as positive, heat out is taken as negative, work out of the cycle is taken as positive, and work into the system is negative. This is the convention. So therefore, now what are the two heat interactions? Heat into the system is positive, therefore Q1. Heat out of the system is negative, that means minus Q2. This is the cyclic integral of del Q. And what is del W? Del W is positive is WE minus WC, going by the convention. So basically, it basically ultimately boils down to law of conservation of energy. That means basically it says energy can neither be created nor be destroyed. This is the first law of thermodynamics for a cycle. First law of thermodynamics for a process. First law of thermodynamics for a process. As I told you, that process is going, for example, this is a process. 1 to 2 is a process. 1 to 2 is a process. 2 to 3 is a process. So therefore, thermodynamic coordinates 1 and 2 is totally different. Here the volume is higher, here the volume is much lower. Here the temperature is lower, here the temperature is higher. Okay. Now, first law of thermodynamics for a process, it says that del Q is equal to del W plus du. That means when you apply heat to the process, it can translate into two physical phenomena. Either it will do some work or it will enhance its internal energy. Du is the U is basically is the internal energy. U is the internal energy. That means when you apply certain amount of heat or work into a system, in that case, the system is taken from initial state to a different state altogether. That is called a process. So that process, in that process, you will have the del Q will have two manifestations. One, it may have work interactions and or it might change the internal energy of the system, which is basically when we heat something, the internal energy of the system changes, right? So this is the first law of thermodynamics for a process. There is one more important uh, term we have to define, what is called enthalpy. Enthalpy is defined as H is equal to U plus PV, where H is equal to enthalpy, U is equal to internal energy, PV is equal to work. Actually, P is the pressure, V is the volume.
Sir, can you please show the diagram once?
Yeah, surely. If you are a fan of such a lousy diagram, I can't help it. Just see. I shall send it across to you. This is a promise. Okay. Maybe
Thank you, sir.
I'll just I'll make a fresh copy of this one because many things which I am talking, I am not able to write here. If I keep on writing, then the progress will be much less. So what I will do is that I will be talking a little more, and whatever I am scribbling, that I will make a fresh copy with proper notes and all, then I'll send it across to you. And this time I will not delay. Probably whatever I'll teach now, you can expect tomorrow. Okay,
Thank you, sir.
right. Now, what we have defined enthalpy, the pressure and volume. Now, what is the unit of pressure? Pressure is basically force per unit area. Force by area. So, what is the unit of pressure? Force is Newton. area is meter square, and what is the volume? Volume is, let us say, meter cube. Actually, L cube, which is meter cube. So P into V actually becomes F by A, which is E, F by A, which is Newton per meter square, into volume V, which is meter cube. So it goes, so finally, F by A into V Newton meter. Newton meter is nothing but, 1 Newton meter is nothing but, it's a force into distance. So this is 1 joule. Yeah. Sorry. Yeah. Sorry. Okay, so this is 1 Newton meter is basically 1 joule. Joule and Newton, these are all names. But actually, if you come down to the fundamentals, it will be the you can take it into kg meter per second square, like that. You can go. So pressure into volume is also joule. Now there are one more thing I would like to discuss about the second law of thermodynamics. So, first law of thermodynamics for a cycle, first law of thermodynamics for a process we have defined. Now, one more thing is that specific heat. What is specific heat? Specific heat basically is the amount of heat required to raise the temperature of a substance by 1 degree. The amount of heat energy that is required to raise the temperature of that substance by 1 degree. Some materials will take more heat to get 1 degree centigrade. Some will take very less heat. The very less heat it takes, it is more sensitive. That is why the uses of these materials will be different in different places because of this specific heat. Now, specific heat, there there are, for solid materials, there is only one specific heat. Specific heat, the heat required to raise the temperature of a substance. This all you have read long ago. To raise the temperature of a substance by 1 degree. Now, for solid, you have a unique specific heat. While for gaseous substance, you have got two specific heats, which is called CP, that means specific heat at constant pressure, and CV, specific heat at constant volume. Constant volume. And the formula for this is that when, for example, you have got a closed container, and you apply some heat here, This is a system, and you apply some heat here, and you contain the system in such a manner the energy can't move or the material cannot move across the boundary. In that case, the internal energy will change. That means it will get heated up. Therefore, internal energy change del U, in that case, it will be M into CV into del T. Del U is equal to change in internal energy. Change in internal energy. If so the volume remains constant, in that case, we have to apply this formula M into CV into del T. If the pressure remains constant, in that case, we call it the enthalpy del H is equal to when pressure is constant. When pressure is constant, we call this change of enthalpy del H is equal to M into Cp into del T. Cp is the specific heat at constant pressure. Here Cp is the specific heat at constant volume. So these are the two important formulas we have to remember. For many environmental systems, you will find that the substances being heated sometimes are solid, sometimes liquid, for which for the solid and for solid and liquid, Cp and Cv is the same. For solid and liquid, Ep is equal to Cv is equal to, you can call it C. But for gaseous substances, you have to identify and you have to you have to make use of the right kind of specific heats. With this, we will take one particular problem with it's a very elementary problem, and it doesn't require much of this thing. Let us say we have time. Okay, let us try. Let's see. A coal-fired power plant converts 1/3 hello. Meeting is going to end in 5 minutes. I don't think I'll be able to complete, but anyway, let us go ahead. If I am unfinished, we shall take up this matter in the next class itself. A coal-fired power plant converts 1/3 of the coal's energy of the coal's energy into electrical power. Electrical energy rather. The electrical power output of the plant is, let us say, 1,000 megawatt. The rest 2/3 of the energy is rejected into the environment. As waste heat. About 15% of the waste heat goes up the chimney and rest is taken away by cooling water. Will you please relog in for some time so that we can complete this job? Because the class is going to end. If you relog in, we will finish the job.
Sir, we have class from 2:15.
Okay, in that case, we will end here itself. In any way, it is going to be over soon. About 15% of the waste heat goes up the chimney and the balance is taken away by the cooling tower. Then cooling water that is drawn from the nearby river. The river has an upstream flow of 100 meter cube per second and an average temperature of 20 degrees centigrade.